Welcome to Physics Tips for Cambridge students. Today I'm going to be focusing on the AS part of the 9702 physics syllabus, that is the usefulness of graphs. Right? So when you are plotting graphs, you are trying to find the relationship between the independent variable and the dependent variable. So graphs give an immediate visual picture of how one variable quantity varies with another. E.g., to find resistance, you all know that resistance is equal to voltage over current. A single set of readings does not indicate the relationship between I and V. So if you take a set of readings and then say five readings of I versus V, or 6 readings, and then you plot a graph, then you can identify the relationship between those. Right, so looking at these graphs that you see over here, this one shows direct proportionality between the two. So direct proportionality, and then this one just shows proportionality, which is not direct. And then this one also just shows proportionality. Okay. Right. Now, there are two conditions for direct proportionality. You know that the first condition is a straight line graph must be obtained. So you should get a straight line graph. The second condition is graph passes through the origin. So looking at the second graph there is no direct proportionality because it's not a straight line graph, although the graph passes through the origin. And then on this one, it is not direct proportionality because although it's a straight line graph, but it does not pass through the origin. So I think we have done that. So here, then you then tell the correct relationship between I and V. Now, this one is for an ohmic conductor, as you know. And then this one is for a semiconductor diode. You know the filament lamp goes the other way, like that. That would be for a filament lamp. Now, this graph here could show the relationship between I and V, but when you've done that, there is an error in the instrument, a systematic error, that is zero error. We expect the broken line is what we expect to get. So suppose you know in theory that you're supposed to get a straight line graph, and then it deviates to the right. It means that there is a zero error somewhere in the instrument, or some type of systematic error. Now, the graphs show the presence of random errors and reduce them by drawing the best line of fit, okay, or the line of best fit. Systematic errors are shown, e.g., zero error on an ammeter, like the third one that I've shown you. Also, you can have what's called an anomalous point, which is a point which lays away from the rest of the points. So plotting a graph helps you to identify this anomalous point. Then the limitation of relationship is shown also, like e.g. when they showing the elastic behavior of objects, right? So if the elastic limit is reached beyond the elastic limit, then you see the graph starts to curve. So you can identify this elastic limit on a extension versus X graph, or force versus extension, that is Hooke's law graph. You can show this limit of elasticity, or elastic limit. Also, graphs enable you to find constants of the equation, which relates to quantities. You can find these by looking or analyzing the gradient and the y-intercept. Also, graphs are used as calibrating curves, or calibration curves. That is to find an unknown point when you have the graph like that. So suppose, let's just delete this. So suppose using this as a calibration curve, there is a current X which you want to find the potential difference associated with that. So you can then identify that. So that's using the graph as a calibration curve. Right, now we always plot, like I said, the independent variable versus the dependent variable. The independent variable goes on the x-axis, the dependent variable goes on the y-axis. So we always plot y versus x, the dependent versus the independent. So we alter the values of x to find values of y. And the equation of the straight line from your mathematics is y is equal to mx plus c. Y is the dependent variable, m is the gradient, x is the independent variable, and c is the y-intercept. That is where the graph touches the y-axis. So that's what we call a y-intercept. So this part here on y versus x. So this is your c. And then you obtain your gradient by that triangle there. So always the triangle that you use for measuring or calculating the gradient must be more than half the the length of the graph that you've drawn, like what I've shown there. It is useful to plot the results of an experiment in the form of a straight line because the slope and the intercept can be found, which can give the values of the constants. The relationship between two variables may be found, so we then identify the variables, that is the independent and the dependent, and then you rearrange the equation so that it is in the form y is equal to mx plus c. Then you can obtain m and c through calculation of the gradient and the intercept respectively. I have this example here to show that is the equation that relates one quantity p to another quantity q is given by p plus b over q squared is equal to k. What graph should be plotted to find the constants k and b? Now if you split this, or if you expand this, you find that if clearing off the fractions, q squared, to remove it from there, you've got to multiply it by q squared both sides. And then this side it cancels, then you remain with that. So you end up with p plus b is equal to kq squared. Now you're told that the variables are p and q. So p is your dependent variable and q is your independent variable in that case. So you have to make it p as the dependent variable on one side and then independent variable and the constants on the other side. So that gives you p is equal to kq squared minus b, and then in the form y is equal to mx plus c, which means that k is analogous to m, like that, and then minus b is analogous to c. So which means c is equal to minus b, and then m is equal to k. So I hope that makes sense. So I'm going to end the video here, and then please comment in the comment section below if you did not get any part of the explanation that I was giving. And please remember to subscribe to the channel and hit the notification bell so that you get alerted of my future videos. Signing out.